Hi folks, this is the Kubernetes SIG cluster lifecycle meeting, the cluster API code walkthroughs. Please be aware we'll be abiding by the CNCF code of conduct, which broadly speaking is be excellent to each other. Right, let's get started. So previously on cluster API code walkthroughs, which I haven't yet uploaded, so I'm still editing those. So previously we looked at the machine controller and the machine set controller, how we stamping out machines, etc. And we paused there because it was a nice cutting off point to move on to the next topic, which is what's actually happening on these machines when they're booting up and how do we make them do things. So today we're going to cover kubeadm, cloud init, which I don't think we've talked about before. Please, someone correct me if my memory is faulty. All right, Stefan's shaking his head in saying no, so I will take that as my memory still being functional. So we will cover that. Right, so I'm going to share my screen. All right, can everyone see my screen?
Yeah.
Cool. And I'm just going to see if I can sort out the participants window before we move on. And the chat window. Okay. Right. Okay, cool. Got a layer sorted. Okay, so right. So today we're going to talk through the Bootstrap controller, I guess. So we looked last time we looked at how machines are being stamped out the machine set controller, some of the interaction with the infrastructure controller, which is responsible for creating it. But now we need to tell a machine what to do. So let's have a look. So if we, so machine set controller stamps out a machine and info machine. So the machine resource is generic. It's what cluster API controllers care about. And then the infra machine is the infrastructure specific machine, which cluster API might get some information from, but it ultimately doesn't know the details of each particular cloud provider. So it's information around like, what region is this machine going to get provision in? What machine type is it? Is it a M5.large in AWS, or is it going to have a certain number of vCPUs for vSphere, etc.? And then the other bit it stamps out and a Bootstrap configuration. And I will turn on word wrapping. There we go. Right. So this Bootstrap configuration is interesting. So we have a machine that's going to get booted in some infrastructure. We need to turn it into a Kubernetes machine. So we talked about, I think I did talk about this briefly. So we need to give some information on this machine. So our machines, infra machines, are not just blank pieces. They're not like, there is some stuff that they are being booted up. They're not being booted with blank disks. I guess the slight exception for this is something like Cluster API Tinkerbell, where in fact the machine hard drives are completely blank. But I think that's a unique case. And I think maybe Metal Cube is also in that situation. But certainly for the majority of the cloud providers, if we're talking about vSphere, we're talking about AWS, Azure, etc., we're starting off with some machine image. So the infra machine is going to will have to have an image. So the image must contain I think I did cover some of this previously. Kube API server must contain kubeadm. It must have the container runtime, which is most cases containerd. Might be Creo for example, for the Red Hat folk. And is there anything? And we must have some sort of initiation system or ignition. So, or Talos or whatever.
Are you sure it's a Kube API server, or did you want to write kubelet?
Kubelet, that's right. You're right.
Okay.
Yes, kubelet. So
maybe
optionally,
kubectl, but I'm not sure. I think it's usually there, but I'm not sure if it's really needed.
it's not needed, but you're right. So optionally, these images can have kubectl, and then they could have pre-baked images. And suddenly VS Code thinks I'm writing YAML. Oh well. So you could have pre-baked is Kube API server, Kube scheduler, Kube controller manager, your choice of CNI, etcd, and sometimes core DNS and kubeproxy. So I think that's it. Is there anything else that you might want to pre-bake? And any other utilities that you might want, but generally those are the things. So what does pre-baked mean? Well, it means we store a copy of the images on the image so that, you know, I've got Docker in my case, so you know, just so that Docker images ls Docker images has a bunch of pre-baked images in my case, and you just want that to be present in the machine, which means that if we're going to start pods and we've got a if not present rule on the manifest, then as long as the image is already present on the machine, it's just going to use that instead of trying to connect to the internet. So reasons you might want to do that is air-gapped environments, right? So that's the most common thing. All of this is done by the image builder project. Hold on, I'm just actually gonna save this somewhere now. Where am I gonna not delete it immediately afterwards? Okay. Back to text file. Right. So the image builder project is here. And that's a bunch of Ansible and Packer, so HashiCorp Packer, which can automate the sort of turning on of machines from scratch and build the image. So use it as Packer and Ansible, but really. So those are the two things that image builder based on. Notice we've got, I think we do have one Red Hatter. I don't know if is the situation different for OpenShift?
Yeah, it's a bit different.
What is it in? Do you mind just briefly describing that?
We have our own building system, just shortly.
And do you need to, like, what's the, so for the image, what's the minimal requirements? Is it sort of just the plain Red Hat Core OS image?
Yeah, it's some CoreOS image plus what you described here.
Cool, thanks. So all of this is when using the core, not core DNS, core cluster API Bootstrap tooling. So this situation might be different for different types of Bootstrap providers. So in the OpenShift environment, they're I think they're able to provision the machine on the fly after it's booted. So in that case, they don't need pre-provision stuff. And there are other projects doing that. And I think both Twilio and VMware are sort of working on things that allow you to do that. And there might even be a demo in tomorrow's Cluster API office hours around a sort of different mode of provisioning. But at least as far as the core Kubernetes, core cluster API controllers work, the principle is that images have all the bits necessary to bootstrap Kubernetes. And the reason we want to do that is certainly in the public cloud or whatever, we want machines to start up as quickly as possible. And the best way to do that is to make sure everything is on there at the start. And so that the time taken to turn on a machine and turn it into Kubernetes mode is, can be less than a minute if possible, if needed. Alberto.
Hey, sorry, my connection is not working, so I couldn't hear Alex before. But for what is worth it, like in OpenShift, we have these immutable images, and then we have something that we call the payload. That is the source of truth for the versions of pretty much everything, including the Kubernetes components. And the way that these get into the operating system is, as you mentioned before, through ignition. The first time that the machine is boot. And after that, we have something that we call machine config operator, which is the component managing the life cycle of this payload. So when this component sees that there is a new version of the payload, it goes and do a in-place rolling upgrade through all the nodes in the cluster. So yeah, that's pretty much it. I guess the key difference is that we have the decoupling from for config from infrastructure, and that we do the in-place upgrades.
Thanks for that. And the reason that might be preferable, I think, in some circumstances is, you're not, so the core cluster API machinery is based around, if you want to do an upgrade or you want to update the OS, then you roll over the machine, as in you delete the machine, you create a new machine and delete the old one. But in some environments, that high level of churn is not suitable. So there are some talks on, say, Netflix, where they said Netflix famously was the ones who were doing the fully immutable operating system. They roll out a new machine every time, but actually, if you see some of their more recent talks, they moved away from that model simply because at their scale, churning over thousands of machines leads to AWS failing to be able to meet their demand. And I've certainly talked to some people where they've done that, and then AWS has contacted them and said, can you please stop? We don't have the infrastructure in that particular region. So that might happen. So it depends on your scale. So certainly on the smaller side, if you're on a smaller organization, then immutable is probably the best way to go. And you've got a sort of guarantee that the machine is in a defined state. And then in a larger environment, you might want some ability to do in-place upgrades, which we haven't yet addressed in the core project. So it's different ways of doing things. Each of those have their pros and cons. And I think certainly when you render, I can't pronounce my V's, but when you're a render like Red Hat and you're able to fully control the payload, then there might not even be that much difference. There is still some guarantee about what you're ending up with because you're in control. Does that make sense to folks? And the background to this is there was a meeting about 2 years ago, I think, in San Francisco, where we all, after a day of discussion, we all decided, well, we finally reached consensus that the core controllers will be based around the sort of immutable kind of mode, and we would revisit mutability later. Yeah, for folks who are there. Right, so okay, so just gonna try and see where is what. Oh no, where's my debugger? Right, so I think gonna do is try and create a cluster and step through what's happening. So I'm just going to check. So what I'm using here is a PR that's not yet in the repo, but it should allow us to see in real time what's happening when we're using tilt. So once that PR's merged, we'll probably do a session on debugging. So I'm just going to see if I've got all this configured correctly. So I've got 30,001. And I'm just going to, I have not been, I just need to pause my sharing. Check that. That's right. Okay. Oh, that's why. That's funny. Me saving that notes.txt stopped tilt from running. Oh, no, I've broken something. What have I broken? Well, oops. I'm gonna stop this again. Oh, I think it's because I added a. Hold on. I think there's something missing from the vSphere. Yeah, there is. That's why. Okay, cool. Okay, so I just turned off. Right, so the vSphere project needs some changes to make this work. So we'll be deploying into AWS, and we'll step through what the Bootstrap controller is going to be doing. Are there any questions whilst I wait for this to get deployed? No. Some comments on Perry, haven't used Tilt for months.
Well, I have one, but it's very specific to tilt only.
Okay.
Nothing related to what you are trying to walk us through, but it's specific to how I try to build using tilt and I ran into some errors. So nothing specific to this topic, but yeah, I'll come back to that later, maybe if you have some time later on.
Okay. All right. I think. All right. We'll save that for the end. All right. So I think we are deployed, and just check. Oh, I've only got the. Hold on, and I will. So I'm just having to got some passwords in stuff as well. So just to check, I've got. Oh yeah. Silly me. I don't think it matters too much. Right. Okay, so I should have this going. Okay, I think we are connected. Right. Okay, so what I've got is, I think this is my test. Yeah, so this is going to be a test cluster. It's fairly basic. It's just a standard AWS. I just going to quickly check that I made up the EC2 instance type from memory, but I just want to check that that's actually correct. Oh, this is really slow now. Too many. Right, m5.large. Yep, that's right. EUS1, 122.2. I did check that we had published images for those, so I think we're good to go, and hopefully this will work. Okay, right. Okay, there we go. So we have the KubeADM controller. So we are now, so as we went before, the machine set controller stamped out a info machine, a machine, and a KubeADM Bootstrap config. So we can have a look at the resources in a minute. I'm just going to shut down Slack for now because that's a distraction. Right. Okay, so we have, so our AWS cluster should be going in provisioning. Right, so got a cluster resource, AWS clusters, that's going to covered before, it's creating all the network infrastructure, so that's happy reconciling away. We have some machine deployment machines, which are, they're just sort of hanging around, not doing anything at the moment. We have, yeah, so our KCP. So we'll cover that in another one, but that KCP is not going to do anything until the cluster is ready. And we had the machine deployment, which is created kind of interesting. 2 replicas, 2 unavailable, 3. Might need to look at that one. Okay, that's interesting. But in any case, I think I requested 3. Let's have a look. So what did I actually ask for? 3. Okay. Right. Okay, I guess that makes sense. Ish. Yeah, need to look at that status. And we have this one KubeADM config template. So that's come from our machine set controller. So our machine deployments stamped out. If we, yeah, our machine set 2 replicas, and then it's created a. So let's have a look at one of these machines. No, that's an AWS machine. Sorry, that one. Right, so we've got a Bootstrap config rep of type of kind KubeADM config with this name. And if we take a look at those, this YAML, so this is the one that's is trying to get reconciled. So it's basically just the spec. The machine set controllers added these annotations and labels. Or it might have gone through the webhooks actually. I think we had a look last time. And so it's now getting reconciled. So we have in our request. So that should match. Yeah, so we're reconciling this one. And if we go back to, so this is fairly new for me. This is years of just being format print ln stuff. So we'll see how this goes. Right, so we're just going to get leg. Let's step over that. Step over that. Okay, so we're just grabbing the resource from the thing. So the request, as covered from the controller one time bits earlier, is just going to have sort of the name of the resource and namespace, and then we need to go and use the client to actually get the resource. And then this common pattern where, you know, if it's not found, then it's not an error because it might have been deleted in the time between the reconcile starting and it actually reaching this point. So we account for that edge case. And if there is if we fail to get the resource, then there's an actual problem we report. So we're now going into this get config owner. So if you have a look at that one, so it returns let's step into it actually. Right. Oh, what have I done? I think I exited the debug. Oh well. Yeah, so we're getting the owner reference from that. So if we saw from the owner reference, we had. Do we have an owner reference? No. Oh no, hold on.
Maybe we just don't have it yet.
Yeah, that's right. Yeah. So that would have exited and not done anything yet. So if we have a look now, yeah, we still don't have anything.
But I'm not sure who would take the ownership, maybe the machine controller.
If we are debugging, we are preventing something else to take ownership.
I'm only
Maybe.
debugging cab BK. It might be because does anything get generated? Does the owner reference get set before the cluster is ready? Maybe not.
I think we would have to take, I think in the machine controller, we would see it, but I'm not 100% sure.
Interesting. So maybe we should reconcile maybe we should intercept our machine controllers as well then. By the way, just only looked this morning. Since we started this series, there has been a bit of a code reorganization. So some of the code has been moved into this internal package. So certainly for the Bootstrap provider, the controller itself is now internal. Well, I think it was just sitting on the top level before, I think. So if it's been moved into internal. So we might start to see some of those changes across the repo. There is an open issue about it, about basically the reason for this is to reduce some of the surface of cluster API and stop people importing the code where they shouldn't be, and that then allows us to make changes and refactor the code internally without being worried about who is using it. I believe that's why we want to do that. Maybe it's the open issues nodding. So I think maybe we'll put a breakpoint on this one. Let's see if I can pull up another.
So I think it's in the machine controller, and there are those reconcile bootstrap and reconcile infrastructure something functions.
Okay.
Further below, and those have something which set the owner.
Right, yeah.
Yeah, and line 254 inside that one.
Oh, okay, right, yeah. Yeah, so I think we covered some of this last time, but does that mean it doesn't get called until, is it waiting for the conditions true? Yes, there we go. Does this mean it doesn't get, is it returning early if it's not? let's have a look at our AWS cluster. So we go. So that's ready. Oh, can't spell. And we've got Bootstrap template cloning. Oh. Yes, so because I paused execution, we're not able to get the webhook. So let's turn that off temporarily. So what happens actually? So if that fails, does that retry? Maybe do need to. That's an interesting one. I think what I will do is we will delete this. Okay, and oh, now we're reconciling again. So what I'm going to do is turn it off. And I'm just going to let that go to completion. Right, so I'm going to delete the cluster and start again. We'll go into KCP next time. I just don't want to do it here. So we'll do it another time. So we'll call that a bust. Let's just go through the logic then. Right, so we are going to reconcile Bootstrap config when we get the owner reference. And if we don't get the owner reference, we return early. We do the usual thing where we get a cluster by name. So we'll see this in most controllers. I think talked about before, we always generally reconciling a resource against the cluster that it belongs to. And then we create a patch helper. So that allows us to make changes to the resource as we're working with it and make sure that those changes get saved back to etcd after we're done. And the other thing that we're doing is setting conditions. So we always want to make sure that whatever work we do, that we make sure that the conditions are updated. And we've seen there's been a few bugs certainly in the providers where the conditions don't get updated correctly. So one thing to be aware of, that if you're ever working with something that's going to affect the condition, make sure you update the condition appropriately as soon as possible, such that if the whatever function that's happening in returns, that the correct status gets saved. Otherwise it gets very confusing for like consumers and end users to find out what's happening. Yeah, so for instance, there is a bug in Kappa around that right now that Fabrizio discovered. Okay, so what we're doing is then we check for the infrastructure ready. So the reason we're doing that should become clear in a minute, but we need a bit of information from the cluster in order to be able to generate a Bootstrap config correctly. Then we are getting the data. I do remember us talking about a bit of this before. So we're creating a data secret. So this Bootstrap resource does not actually contain the Bootstrap information data itself. That's saved separately in a secret. The Bootstrap it's a CRD that is a control point for the information, but it's not the information itself. So and that essentially is also allows other providers, other Bootstrap providers to, with their own Bootstrap mechanisms, to be able to plug in. So there is a convention around what the secret name should be for a machine. So this config.owner, so we go to that. It's yeah, so on the machine resource, let's see, I think it's going to take a while to delete. Oh no, it's all gone. All right. Okay. I hate that. I'm not still trying to debug things, am I? Oh, got. Just gonna restart these controllers. Let's make sure. Okay. Okay. Right. Right. So look at that machine again. Uh, oh, don't want to watch. Right. There you go. Oh, I guess it doesn't get set until later. Okay. So we have the, yeah, so I think this Bootstrap data secret, that name is on the machine resource, right? Not the Kubernetes config. Config owner should be the machine. Yeah. So, okay. That makes sense. So we get that. So we're going to have to wait a while for get the infrastructure ready. Oh, hold on. Yeah, so the machine ready. So, right, infrastructure ready in this context is not the cluster. It's the machine itself. So we're going to be doing this refresh Bootstrap token, which if it's not ready, so we'll just have a look at that. And then the machine pool will handle separately, but there's a different mechanism for that. So we'll come to in a minute. And then there's two different mechanisms for control plane machines and workers, but we'll take workers for the first instance. So first of all, we need to get a couple of things. So if we go back, what do we need to oh, thanks. Thanks for bits, yeah. Give me a command. Oh. Why is that? Why are the flags not working?
Sorry, cluster cut will describe a cluster, name of the cluster,
Oh, okay.
and then disable. I don't remember the. You can.
Let's use the
Right.
help.
It's there in Zoom chat.
Uh,
No, that's what I'm not using. So I think it's disable group, disable no echo.
disable no echo. Okay. Show condition all.
There we go. Cool.
So basically, these expand, show all the condition for all the object. You can also show use a show condition machine if you want to see only the condition for the machine, stuff like that.
Cool.
And disable grouping, basically, if two machines are of the same state, they get exploded, and disable no echo shows you the Bootstrap and the infrastructure machine.
Oh, great. Cool.
So it is the maximum detail that you can get now.
I think I might, right, we'll put that in the notes, and I'm probably gonna end up setting up an alias for that in my shell. Right, so actually, why don't we change this to a markdown doc? That's better, isn't it? So what do we need to get a node to join a cluster? So we need to get kubelet essentially to register on to the API server as a node. And so we need a way for kubelet to authenticate with the control plane. We need the control plane endpoint itself. We need some way to verify that we really are talking to the control plane, right? So we want to prevent man in the middle attacks, someone intercepting, sitting in between the node and the control plane. So we need some mechanism to do that as well, and we need authorization for the node to join the cluster, right? So both authentication and authorization. So this is where kubeadm comes in. So I don't know if we'll be able to see that. So we are, I think, where are we on that? Node conditions. Well, I probably need to apply CNI even. It's not. Do I have a CNI
this is
manifest?
Not conditionals already CNI.
I used to just have like a blob of
Use
CNI.
the Calico one. Maybe
Yeah,
it's
probably.
it should be in the quick start somewhere.
Actually, why don't we just talk about how did I know that was just CNI? Okay, so this is really common. People ask. So we, if you look at our machines, so we've got a bunch of machines that have joined the cluster somehow. They've all got provider IDs, but they're not ready. They're not well, and they're running. So what's going on? So we look at the conditions here. It's got no conditions failed. So what conditions do we care about? So if we get the get kubeconfig test AWS, right? So we're going to connect to the workload cluster. Oops. Do it easy. So if we take one of these nodes, doesn't really matter which one, because they're all in the same state. So we have, well, there's a number of different ways that they can give us we can find out what's happening. So one is we can look at the node and we can see container runtime network not ready. So that's one clear case that we know CNI isn't working. And then additionally even says that CNI plugin not initialized. The other way you might notice that this is the case is if you look at all the pods that are running, then core DNS is impending. So core DNS will not start until CNI is up. So if you ever see that, like somebody asks you, core DNS isn't running and none of my workloads are running, then that's a clear smell that they haven't installed the CNI yet. So it's just rightly, we're going to go to the I can't remember the URL fan. So this is not important specifically for demonstrating. So machines will join the cluster as is, but just for completeness, we will get installed the CNI. I actually like the dark thing. Let's change that back. Where is the CNI? And make sure I connected to the right thing. Oh, okay, cluster info. Right. Make sure you apply this to the workload cluster, not your kind cluster, otherwise bad things are going to happen. Interesting. Right. So those nodes will return ready in a bit. And the other thing we probably did, so I'm just going to close that for now. So if we have a look at our secrets, we've got a bunch of secrets for each of these machines. So if we have a look at test AWS MD LZ. Don't know why I typed that out manually. So we've got this Bootstrap YAML. Right, so we now have this configuration. So this is not Kubernetes now. So we have a cloud init configuration file. And so cloud init's a thing that runs on first boot on many cloud infrastructure, originally designed for AWS by Canonical for the Ubuntu project, and lots of other projects adopted it. And then concurrently or a little bit after, the CoreOS effort emerged and the CoreOS team developed their own Go-based bootstrapping system called Ignition. And as CoreOS became part of Red Hat, that became the thing that was used by Red Hat CoreOS. So the slightly different philosophies. The cloud init's all written in Python, requires a Python subsystem. It does lots and lots of different things. Whereas Ignition is quite focused around containers and how container runtimes and Kubernetes, and is written in Go, so you don't need a Python subsystem. So pros and cons each one. Cloud Init's got a lot more features in some ways. Ignition is nice, small, and fast to execute, and probably at this stage has a better sort of test coverage and bits and places. So we have this kubeadm config. So as I said before, we need to point at the control plane. We need to we need the endpoint. We need to know what this machine is going to connect to. So that's that bit, this API server endpoint. So that's why this Bootstrap configuration can't get generated until the cluster infrastructure is in place. The CA cert hashes. So this is a PKCS12 signature of the CA hash. I can't remember the details. Did it a long time ago. But it's so there's two ways we could prove that the control plane is what it says it is. We could either provide the entire CA certificate, and we'd have a big blob of YAML which contains the entire certificate. We can say if you apply this hashing algorithm, consistent hashing algorithm, then you should get this output. And it's a way to guarantee, well, I guess you could have collisions, but SHA-256, extremely unlikely that as long as the CA set matches the signature, then we know that this node really is talking to that control plane. There's no man in the middle potentially intercepting that traffic. And this Bootstrap token, which is the authentication piece. So this allows the machine to authenticate to the API server to be able to join the cluster. So, and then finally, we have the sort of cloud provider. So these were templated out in our kubeadm config template. Yeah, and I forgot what this placeholder bit business is about. So what? Oh, it's some Windows thing. Okay, wasn't aware of that. We're doing some stuff for Windows, it appears. Yeah, and then finally this Sentinel. So some providers will track files created on each machine. So Azure does this as a way of marking that the machine is correctly provisioned. Yeah, so we need to generate this token, and we are generating it for each machine. So if we go back to the kubeadm config, so I think that where is the okay, so we need to, okay, so here we go. So reconcile discovery. So we're filling in the control plane endpoint. So we're generating the hashes for the cluster CA set. And create that. So then we have the create token. So this is the bits and pieces that we. So this is code that also exists in kubeadm. So what you can do, so normally when you're executing kubeadm is you log on, you SSH onto one of the control planes and you run kubeadm, I forget the details, kubeadm token generate, and then you get back saying run this command on the machine you want to join. Cluster API philosophically does no SSH. We are not SSHing into things. All our interaction with the workload cluster is through the workload cluster's own Kubernetes API server endpoint. And if we can do that, then we can already generate the token. So this is logic which is pretty much, in some ways, copy pasted from, not copy pasted. It is copied from kubeadm because kubeadm currently in its current form does not exist as a library that you can consume, and it is in the Kubernetes repo. So we don't want to import all of Kubernetes into the cluster API project because that will make us very restricted in terms of versions, and then also just importing in millions and millions of lines of code is for something that for just a small function is probably not ideal. So we simply have reproduced that code. So importantly, we are this, I think this generate bootstrap token is just generate some bytes. I think, is that all it does? I guess we need to save that somewhere. Right, okay. Oh yeah, that's what we do. So we are creating a Kubernetes secret, give it title. So this, the API server knows that this is a Bootstrap token. So I think, is that right? So I think the Kubernetes API server will identify it if a secret has that type.
Yeah, there are some controller that treats a secret of type Bootstrap token in a slightly different way. And
Okay.
so it is documented in main Kubernetes repo, how to do Bootstrap secrets and which controller you have to enable by default, but Kubernetes does this for you when you do init.
Cool. So that random bytes that we created is in here. We set an expiration. That TTL is defaulted to 15 minutes. It is configurable as a flag on the controller itself. And we then give it some groups. So we're saying it's in this Bootstrappers node. So we'll come back to this at an earlier time, but well, maybe when we cover control planes. But when we do initiate the control plane, kubeadm creates a bunch of groups with certain permissions. One of those is this node token, which allows the kubelet, if it presents this token, to register on the API server as a node. So we have this cloud init stuff. Oh, that has that, and that. So if we go on to one of these machines, right, just for those who work on the AWS Pride, they've seen I'm not using SSH, using AWS Session Manager. In fact, you don't have to use it with AWS. This works with anything as long as you install the agent and a registration token with AWS. This allows you to you don't have to use a Bastion node. You don't actually need direct connectivity to the node, as long as the node that's provisioned is able to contact AWS APIs, then you are able to get onto the machine. It's all controlled through AWS access permission. The way it works is that it sets up a two-way WebSocket tunnel from the machine connects to AWS via WebSockets, and then you connect via WebSocket to AWS, and then you connect it together. So it's much easier, at least from an AWS perspective, when you've got machines behind the firewall to be able to connect to. You don't have to worry about like joining networks together, setting up VPNs, or putting a Bastion instance on a public IP and changing security group rules. So there's a plugin for Mac OS. I believe it's in Brew. Can't remember. Let's just check that. No, oh, maybe not. Pretty certain there is a session manager plugin for in Brew itself, so you can just install that via Cask. But anyway, so that's that handy little tip from my perspective. There are a few little oddities. You can also do this with the EC2 console as well. So you can just go into AWS console and just connect through that. So it does the same thing. It's just once you're doing it inside the web browser, it like copy paste gets a bit odd, and doing right click inside the browser. So this is easier. Right. So if we have a look at one of these machines, and let's have a look at systemd. So if you're going to start debugging clusters and machine bootstrap, then probably worth familiarizing yourself with systemd. So systemctl status just shows the sort of basically the list of services, and I think there is also, so you can see this SSM agent. So that's what's allowing me to connect. So that's just running, and then it forks a session worker for me. We've got our kubepod slice, I think. Can anyone remember the critical path command offhand? That one's interesting, I think. Oh, maybe not. Right. The other thing is, if you
I think I found it. Systemd analyze and then critical chain.
systemd,
Minus analyze, it's one binary. Analyze. I just
Right.
pasted it in
spell it
Zoom.
out.
A second. I posted in Zoom. There it is.
Oh yeah, that's one. That is the one. Yeah. Okay, so let's do kubelet. Yeah, okay. So to get that's interesting. Right, so to get kubelet running, we need to run a bunch of services. Cloud Init appears a few times in this. So there's actually a bunch of different oh, it's different on Ubuntu. What are the system units on Ubuntu 18? I thought this is an old version.
I think you can write a systemctl cat and then a unit name, and then you will also see the file path to the unit file. Should be in red.
Oh, right, okay. Sorry, I'm used to Fedora, it's a bit different. Okay, so, right. There's a bunch of Cloud Init services. So there's Cloud Init, Cloud Config, and Cloud Final. So Cloud Init actually executes 3 times during machine startup. So Cloud Init, if we have a look at that one, just executes USR bin Cloud Init init. And what that does is, again, this is going to be slightly different because of the weird things we have in AWS. So if I go in warlib Cloud Init, warlib Cloud, yeah, so if you're ever debugging Cloud Init, this is what you want to do. Oh yeah, thanks, Stefan. So user data, so what can be compressed in AWS it is. So I think one of these is the uncompressed version. There we go. Right. So in the AWS case, we're doing some funky stuff. I might have mentioned before, but at least it's been in the security audit we talked about, that we actually store the secrets in AWS Secrets Manager, and then we reconstruct them and reconstruct the real user data. This is to prevent, more specifically for the control plane, like someone from stealing the certificates from stealing the key material from EC2 console. Less important for worker nodes, but it can still prevent token being stolen. So we on that. So and then the other thing you want to look at, that you might want to look at, is the cloud.cfg. This cloud.cfg says when things execute. So there's a bunch of things that we represent in the kubeadm config. We don't have everything. Not everything in the kubeadm config has a one-to-one mapping with what is possible in Cloud Init. So you can see the order of things that execute. So for instance, in that Cloud Init thing, we are writing all the files. So we write the kubeadm file as one of the first things that happen. Set up the SSH keys. I think that's primarily used by vSphere, for instance, less so on the other cloud providers. In Cloud Config, is actually where we run kubeadm as well. So and in Cloud Final, I think for the purposes of cluster API, it doesn't do much at all. Yeah, not really. Yeah, so as you can see, there's a lot of it's tied in with other sort of configuration management systems like Puppet Chef, Salt, and Collective. So that's so used to use that a lot. I think Dominic is on the call, has a lot of experience with using that as well. Yeah, so given that, so some of the issues that you might see is within ordering. So that cloud.cfg can be unique per cloud, per operating system. So different Linux distributions or even Windows itself might take a different stance on what the order of execution should be. And then they also might take a stance that for each different cloud, it should be different. So we've tried to make them the same in image. I don't think we're actually controlling them directly in the image builder. And I think there is an open issue whether or not that should be done. So if you ever see people report issues with difference with operating systems, the one thing to check is always this cloud.cfg. And then also to check what is in warlib instance, warlib cloud instance. And actually the first thing you should always check is in warlog is check cloud init output.log. So this will have actually tell you, this is where you're actually going to see kubeadm output. So all this pre-flight, kubelet start, etc. is coming from kubeadm.
And I think that file is only written after Cloud Init returns. So if Cloud Init is still stuck because of some retries for 20 minutes, it could be that this file is just missing until it fails eventually.
Yeah, that's right. So it's not quite right at the end, I think. So it's the log only gets written to at the end of each module being processed. So
yeah, and if you run SSH, does everything done. Then it's the end. But
is it?
No, it's just when you run SSH, is basically called kubeadm, and kubeadm then does all your stuff. Then it's just one module which does almost everything, and then it feels like. But yeah,
that's right. So what you will see if you're especially on vSphere, because on vSphere you can actually get on the SSH really quickly, and if it is taking some time, then you might just see text up to here and then nothing for a while. It might be like 10 minutes later because I don't know, something's control plane is moving about doing stuff, and then it prints out finally that might be a success or a failure. So that anytime you might see nodes fail to register or any other issue with the machine, cloud init output.log is my first go-to, and it should at least say this at the end. And if it doesn't say it, say cloud init, like this final 2 log lines, then cloud init's still in the middle of executing. And you should probably see that in the system state CTL status cloud config. So cloud config is the actual instantiation of cloud init that's going to run kubeadm. So that's the one you're interested in. Then we can see it's active and exited. So it finished with the success. So if that was still running, you'd see active, no exited, and you wouldn't see the status code. And something from Dominic. Yeah, you're right. Yeah, so you can use your favorite combination of PS command. I have not used PSAUXWWF. What? Oh yeah, that's I think I just used PS capital AF, but that your favorite version of the incantation of PS can show you things. So I think with the version that Dominic signed with it, you see the tree. So you can see what command has forked and then I've forgotten the thing in Linux, but yeah, it's then created the new process. So you would see kubeadm being executed by cloud config. As you can see PS being executed by my several nested layers deep of su sudo sh bash and then Amazon SSM agent up all the way back up to the cloud, etc. Yeah, so that's those are really the important things about machine joins. And I think we are coming up on time. So I think at this stage, we'll take questions. Any questions? Anything I've missed? No? All right.
I have one idea. Maybe you talked about this before joining, but maybe interesting to show, to describe how the Bootstrap provider basically orchestrate the first node joining and the other, the first node initializing and the other joining.
You mean control plane in it and join?
No, it is. I mean that the Bootstrap provider basically has a config map that uses it as a lock mechanism for allowing only the first control plane to init and the other to wait.
Oh, I haven't covered that. I'm going to cover that in there later, I think. So I've
Okay.
only been covering worker nodes in this one.
Okay. So not an issue then.
No, next week, I think we'll do that. Yeah, that is an important one. Make sure I mention it next week, I think. Oh yeah, and Stefan's noted journal CTLF is super useful as well for monitoring continued execution, apart from the audit logs.
Yeah, grep -v audit always. Or someone has to fix the config in image builder.
Yeah, there is an open issue to get rid of that audit. So the other thing is, as Chris Nova like to call it, so the journal CTL FU kubelet gets you the individual unit. So
interesting output.
that is an interesting output. What? I don't even know what. Are we missing stuff in image builder?
I'm not sure that's related to that. Not sure how flex volume should work.
I don't even know what node agent UDS is. I'm not a CSI expert. Or, well, it's not even CSI at this stage.
I think it's just something with a flex volume driver thing.
So, should we have a quick look? Curious now. I guess if you added
it's an
an
option in
additional
Canonical,
flex volume driver, which we don't care about since we're switching to CSI. Okay, I think we're safe there.
Maybe you want to talk a bit about ongoing work and I don't know, open issues, things like ignition and decoupling. I don't know.
Yeah, that's right. So the current state of things is that Bootstrap controller just shown is very, very much tied to Cloud Init. And if you are Red Hat, for example, you've got to write your own Bootstrap controller. You're not really able to use the core cluster API controllers today. And the same is true for the Kinrope Microsoft lot and Talos, who've got their own Bootstrap provider, which I'm not used at all. Completely their own thing. So there's two major PRs. Well, it's one PR in flight, which is to add support for ignition to CatBK, which we're looking to get in for 1.1. But however, this is still going to be Ignition v2. Fedora CoreOS and Red Hat CoreOS use Ignition v3, which is a slightly different format. It's the same library that we're using, so we could add it, but even this in itself would not be compatible with Fedora CoreOS today. And also, ultimately, kubeadm is not really what we want to use to join worker nodes either, because we saw that the Bootstrap token is created. There is But one of the issues is we don't know the machine name ahead of time because AWS is creating a machine, it's creating the instance. So for KubeADM token, we can only give like a blank check to say, yeah, sure, you can register a node, but you could register as any node you like. You could register as a control plane node technically, and then that's not ideal. So there is a proposal that needs to be implemented. So we need, the proposal is there. We need to actually build it to replace the KubeADM with using some trusted mechanism to ensure the node is what it says it is. So for example, in AWS, that's using instance identity documents. So we can actually get that from, well, on this node. Oh, there should be a signature for that. Yeah, anyway, looking at details, probably not. Anyway, you get a signed document from AWS that you can hand off to the control plane to say, I am who I say I am, proven by AWS, and this is my instance ID. Or you can do a challenge response mechanism, say with TPMs on vSphere or bare metal. So there's different ways where a machine is able to prove who it says it is. And if we can prove that it belongs to this cluster, then we can let it onto the cluster securely, and we don't have to use Bootstrap tokens anymore. So that's something we definitely want to do as we move towards production V1, etc. The other issue is, can we make it so you can plug in your own Bootstrapper completely, like without having to add code to the cluster API project that understands each of these Bootstrappers? Like, it's not ideal that cluster API has cloud in its specific code and that we're adding ignition code, and or we might add Talos. So is there another way to do that? So there is an open issue as well. This one, 5294, says bunch of use cases. We're out of time, but yeah, take a look. Like, we need to figure this out. And with that, call it. So thanks, everyone. We'll reconvene in a week and cover control planes. Right. Thanks.
You guys, cheers.